when you look at this, treating a product of two fractions is no different than what we just got finished doing. Step one is to factor everything completely. And step two is to cancel common factors. Okay, so it's no different than what we just did, only we're doing it for two fractions at the same time, okay, or three, or however many are involved. So when we look at this, step one is just to factor completely. So we have this trinomial with a leading coefficient of 1, so we can find binomial factors here. And we find those by identifying what two factors of -2 have a sum of +1. So +2 and -1. So there's the factors of our numerator. In our denominator, we can remove any common factors. So between these two terms, we can remove a common factor of 4x squared, leaving an x minus 3. In the second fraction, looking at the numerator, we can remove a common factor of 2x, leaving an x plus 1. And in the denominator, we have the difference of squares. So if we identify what numbers are being squared here, we can factor that into the sum and difference of those terms. So x's and 1's, take the sum of them times the difference of them. Okay, so that's the first step, factor completely. Once you factor, okay, then it becomes exact same steps as in simplifying a single rational expression. Because when you multiply these, it really just becomes one fraction, and just multiply across the top, multiply across the bottom. So you can cancel factors between the two. So if you just start in one place or the other, whichever one has the fewest number of factors is usually the best to start, and just go factor by factor. So x plus 2's don't cancel. X minus 1's do, so I can cancel that. The numbers 2 does cancel with a 4, leaving a 2. This x cancels with one of these x's, leaving an x in the denominator. X plus 1's do cancel as well. So now we can simplify this, just multiply across the top. The only factor left is x plus 2. And then across the bottom, there's several factors, so we multiply them. The monomials first, 2 times x, and then the binomial, x minus 3. Okay, so the first part, when you cancel this, you simplify the fraction. The second part to this is going to be to identify any domain restrictions. So you have to go through and look which factors got canceled from the denominator. So we did cancel an x, but did we cancel all the x's? No, so you don't have to worry about that. We didn't cancel the x minus 3. Don't worry about it. We did cancel the x plus 1. So what value of x do we know cannot exist in the denominator? A 1. And then what about for this factor x minus 1? What other value of x cannot exist in the denominator? Oops, this one is a -1, and this one is a +1. So when you're looking at those, your only two restricted values are x cannot be, so not equal to. Write the smaller number first, followed by 1. And so this would be your restrictions. Okay, now again, if I had asked this question, or given you the same problem, but asked you what is the domain of this, the domain is all real numbers except for 0, 3, -1, +1. You'd include all of those. But here, the fact that it can't be 0 and it can't be 3 is shown in that simplified form. The values that aren't shown in that simplified form are the ones that you need to include. Does that kind of make sense, that little distinction? The ones that are apparent and ones that are not apparent? That's kind of the phrasing I'll use for that.